Hello, welcome to the video. This one is on soil problems and conservation, and we're going to begin kind of with the biggest problem for soils, and that's soil erosion. And it's caused mainly just by the water and the wind. And so the forces of nature, rain, for instance, would be the water aspect, and the wind blowing and moving kind of loose particles around. And so the big problem with soil erosion is that we lose the particles, especially those really valuable organic material, the ones that contain the nutrients the plants need. Those ones are typically on the top layer of the soil. They're usually the lightest and loosest particles, and so they're the easiest to be washed or blown away. And what happens is as that top layer of soil erodes, we lose the nutrients and we have to add in extra fertilizers. So what does soil erosion look like? This is a great picture of soil erosion. As you see in the background here, we've got some sort of slope on this farmland, and there's no kind of plants or anything on it at this time. It's probably an annual crop that has been harvested and removed. As the raindrops are falling, those raindrops are loosening the soil particles, and so it's little kind of like miniature explosions. As they hit, they send soil particles flying, and they loosen them from the ground. And once they become detached, they can flow down through these channels called gullies, and you can see how brown this water is with the sediments from the farmland up here. As they run down the hill, they get deposited at the bottom, and one of the things that happens is as they are deposited, they kind of fill in the gaps in the soil layer down there. And so if you picture the soil, if you looked really closely, there's little kind of pockets where air can get down into the soil, and these new particles are going to wash and kind of catch in them. And so they kind of reduce how much water can enter the soils downhill from this field. They also reduce how much air gets in it, and so it kind of contributes even more to erosion, because now the water can't get down into the soil and be absorbed kind of like a sponge. It just kind of washes over the surface of the soil and carries more particles with it as it goes. And so it's kind of this compounding positive feedback loop. The Dust Bowl is probably the greatest example in our history of soil erosion. And so the Great Plains generally have low precipitation just as their climate. There's not a lot of rain out there, but what they do have are the native grasses have very deep roots, and so they kind of hold the soil in. They're very deep roots because in those drought periods, they could still access the water table below. What happened is we started tilling up these natural crops, and as we removed them and removed those roots, it loosened up the soil. There's really great soil for growing stuff, and so we planted a lot of annual crops, things that aren't there part of the year. And what happened is there was a very severe drought, and that drought led to our annual crops not being able to grow, and their roots weren't deep because they grow every single year. They don't have time to get deep in the soil. And so what it created was a lot of loose soil. The Dust Bowl region is this one right here. Kansas, Oklahoma, Texas, Colorado, and New Mexico. And you can see this is a picture from the 1930s, what the ground looked like out there. Hardly any kind of ground cover. And so you're losing a lot of that soil due to wind. And I think dirt and dust particles from the plains out here were blown as far as Washington, D.C. and New York City. And so really great losses in topsoil. Another problem is mineral depletion, and this happens with really intensive monocultures. And so what happens, we've got a crop plant, in this case it's a tomato. That tomato's taking the same amount of nutrients from the soil, whether it's nitrogen, phosphorus, potassium. Those are kind of our essential nutrients. As the tomatoes grow, those nutrients get deposited in the tomatoes to be there for the seeds. The problem is when we harvest the tomatoes, the people aren't consuming them or leaving the tomatoes on the ground of their farm. They're being shipped off to Publix or Winn-Dixie in Jacksonville, and we eat the tomatoes, and those minerals don't make it back into the soil. The nutrients don't make it back into the soil. And so what the farmer is left to do, they get some minerals back from the dead crop material, right? There's not a lot of people eating the tomato leaves, so they can leave those behind, but they have to add in the inorganic fertilizers to supplement them and allow the plants to be grown next year. And so we're kind of exporting the nutrients unintentionally through transporting off these fruits and vegetables, and so that can lead to mineral depletion if we don't supplement with the fertilizers. Soil salinization is a huge problem with soil these days. This is the gradual accumulation of salt. So salinization is talking salinity. Salinity means salt, and so this comes from irrigating using poor irrigation techniques, and it happens mostly in these arid and semi-arid regions, areas that aren't very good at growing plants in the first place. When we irrigate them heavily and we're not doing it wisely, it can lead to this. And what happens is what you see in the picture here, this white stuff on the top of the soil where it's cracked here is salt, and that salt is toxic to plants, right? The salt is going to pool water out of the plant cells and deplete the amount of water there, and they're going to die. And so soil salinization, this is the process that it happens. So under normal circumstances, the rain falls, the water gets into the soil, the plants use the rain, the water, and it's evapotransported up back into the atmosphere. And so you kind of have this nice cycle where the water table stays low. Remember, as the water flows down through the soil, it carries soluble compounds like salt and nitrates and phosphates and other components of the soil there, but salt being the important one here. If we clear the forest and we remove the amount of plants on it, and then go as far as to irrigate, and so this one here we're talking some irrigation, that water, rather than being used by the plants at the surface, starts building up and building up and building up underneath the soil, and so it pushes those soluble compounds like salt up to the surface and into the root area of the plants, and that's going to lead to salinization of the soils, and so the plants are going to start to get that salt in the roots and lose their water and eventually die, as you can see in the picture here. And we even get some salt buildup on the surface where it is puddling up and then drying up and leaving behind the salts. This is also true in heavy irrigation too. So if we're really heavily irrigating it, it brings that water up to the point where you get water settling on the surface, and then as it dries, that settling water is called waterlogging. As it dries, that soil is going to build up a layer of salt on top of it, and at that point you really need to flush the soil and let it drain completely back down, and that's a long period of time without kind of plants growing on it. There are some plants that are salt tolerant and can be grown in salty soils, and so kind of the process to fix salinization is to focus on those plants, let them grow to hold the soil particles in place, but minimize the amount of irrigation you're doing to kind of let that salt flush off the surface and get pushed back down deeper into the soil below where the plant roots will go. And then once you switch back to growing your cash crops or your sustenance crops, you need to be really careful that it's properly drained and you don't have that water building up. This can be solved if you get just solid drainage of the water and you let the water flow through, the plants use what they need, and then hopefully you could recycle that water and respray and keep it kind of going. Desertification is the other major soil issue. What happens here is that we take this fertile rangeland, productive farmland, and it becomes a non-productive desert. And the biggest reason why things become deserts or get turned into deserts is the loss of the trees. And you can see this picture here is an example of this in action here. You can see there's not very much plants growing here. They're spending a lot of water to grow these little sickly trees here. And a big issue over in Africa, and so this is the Sahara Desert, this large dark red spot. The orange color is susceptible to become deserts, and so it could become a desert as people are using up the brushwood for fuel, right? So cutting down trees is a huge cause of this. Overgrazing is another big cause of this. If you lose the plants in the soil, then the water that falls just runs straight through, where the plants will capture some of that water and they'll bring it back up to the surface through evapotranspiration, and that water that they bring back up can then form clouds and rain back down. And so it's kind of a cycle that the plants are a major part of, the water cycle. Without them there's nothing to keep the water there, and you lose out on it. And without the water, the plants can't survive, and it becomes a desert. Some soil conservation techniques. So how can we make sure that our soil lasts and doesn't go bad? And one of them is through conservation tillage. Essentially what this is you leave the crop from last year. So, for example, if you're a corn farmer, this would be what your field would look like. You would be concerned with the ears of corn on the stalks, but the stalks themselves, they're not really that valuable to sell. In fact, you probably couldn't sell them. So what you would do is you would grind them up and till them right back into the soil, and you can see all the dead stalks from the previous years in here. What that leaves is it leaves some organic material that can decompose and deposit minerals back into the soil. The great thing about it is it's very slow release of minerals, slow enough that plants are able to use them as they become available. So it's kind of this like long-term fertilizing using old plant material that you previously have grown. So that's a really smart way to improve soil fertility. Another good way is crop rotation, and so this is kind of cartoony down here, but it shows you the example of crop rotation. It's just changing where you grow which crops over a certain period of years, and so you might do a 3 years where your farm is split up like this with your corn on the left side and your radishes in the middle and your peppers on the right side, and then you rotate it. The next 3 years you shift the corn to the other side. And the main reason here is that the different crops have different nutrient requirements, and this way you're not depleting one area significantly by growing corn there endlessly. You're switching it out. Another big one is contour plowing, strip contouring, and terracing. These are all to reduce erosion. The first one, contour plowing, is to use the slope of the land and the shape of your fields to kind of reduce that erosion. And so this is contour plowing. If you've got a downward slope in this direction, it makes a lot of sense to grow your crops on these contours, these lines that you can see here, because now as the water runs down, it doesn't have a free alley where it can just wash and take all your soil away. Like if the water was running downhill here, it could go straight down these alleys and take a lot of soil with it. This way, it makes it just a tiny little bit, and then it hits some plants, and the plants slow it down, and then it makes a tiny little bit, and it hits some plants and slow it down even more. So that's contour plowing. Strip cropping is another way. It's alternating strips of crops along natural contours. So it's kind of one step further here. Now we're going to use different crops through it, and this can be used with crop rotation, but it also reduces that flow of water even further, because now you're hitting different sizes of roots, different depth of roots. The plants are going to grow at different times of the year, and so right here the corn looks fairly short for what corn grows. The oats look very, very short, and the hay also looks fairly short here too, but you still have some height to it. If this were all oats, it would be very flat ground, and you'd probably have very susceptible to erosion, where here, if the water is flowing down, it might run quickly over the hay, but it's going to slow down big time in the corn, and then it'll speed up again and slow down. So it's all about slowing down the flow of water. The last one's terracing, and terracing is used in really mountainous, hilly regions, and it's used to prevent that water flow and the loss of soil erosion here. So this is terracing in China, rice farming, and you can picture what this land would look like without the terraces. It's a pretty steep slope, and it's a pretty ingenious method that they've used here to create these pools where the water stays and is captured rather than flowing down and taking soil particles with it. And so this is where they grow rice, or how rice is grown in this mountainous regions in China. Another ways we can preserve the soil fertility is through organic fertilizers. Like I said earlier, these ones are better because the nutrients are available over time as organic material decomposes. The inorganics are very fast acting but short lasting because they rush through the soil, and when they rush through the soil, they can actually get down into the groundwater and end up polluting it. So they work great in the short term, but they run straight through because they're so water soluble. They'll flow wherever the water goes. Soil reclamation is an important thing. This is where we stabilize the land to prevent future erosion, and we restore it to its former fertility. The biggest thing here is a shelter belt, and what that is a row of trees, and the row of trees is going to do two things. It's going to reduce the wind that is blowing on the soil, and it's going to reduce the water flow, right? As that water encounters tree roots, it's going to be slowed down, and it's reducing both of these to allow soils to build up. And then once the soil starts building up, we can focus on getting that fertility back in the soil. And so that's what it would look like here. This would be the Great Plains in the United States. As the wind blows, right, it encounters this band of trees, which is going to slow it down, and then it'll blow and hit trees and slow it down. So there's no room for those particles to go. The great thing is the trees will be there year round too, and the roots are very deep, and they'll be there year round. So this is going to be kind of our counter to another dust bowl. If we get hit by a drought, those tree roots are still going to be in place and blocking the sediments from flowing away. This is used in Africa, or is going to be used in Africa, in the process of being used in Africa to combat this expanding Sahara Desert. And what it's called is the Green Belt Movement. And essentially, this started in Kenya, which is over here. Essentially, they're going to build a row of trees the entire way across Africa and prevent that desertification of the Sahara to advance any further into this really fertile tropical rainforest region of Africa. And this is what it looks like right here. There's their green belt straight across, and it's 7,775 kilometers worth of trees to prevent it. It's essentially one giant shelter belt. And then the last thing, there's a couple soil conservation laws to be aware of. The Soil Conservation Act, this was put in to prevent another dust bowl from happening and to help solve the current one when it was enacted. Essentially, we've got a government agency now that's in charge of taking care of the soils. And then more recently, 1985, now we are looking at which lands are highly erodible and what can we do to help protect them. And so those farmers that are on those lands have to change their practices. And we also have this conservation reserve program, which will actually pay some farmers not to farm that highly erodible land, and that prevents that erosion from taking place. That's all for the video, soil problems and soil conservation. Thank you for watching. Please bring notes and be prepared to discuss in class tomorrow. Thank you.